Alright, this is lesson 44, adding and subtracting polynomials. This is for Algebra 1. So today we're talking about combining like terms. And it's kind of like, let's say I give you like a big sack of money and I'm like, okay, it's all mixed up. There's hundreds, there's 50s, there's 10s, there's ones, there's quarters, pennies, dollars, nickels, dimes. Okay? All sorts of money in this bag, and it's all mixed up. I'm like, you could have as much as you want of it as you like, and so you need to count it all, right? And let's just say that I'm going to say, well, you take all that money, and then whatever you fit, you need to put it into another bag and give it to your sibling, okay? Because that's part of the deal. So how would you count all the money?
Split it.
What do you mean split it? How would you count it? Let's say I gave you this big sack of money. I'm like, oh, it's been in my garage. I don't really need it. Take it out. How would you?
Change, right?
There's all sorts. There's.
Like you show different types of money in like a different pile and like count them.
There you go. Yeah.
That's nice.
You can just like reach in the bag, grab a handful of money and count it, and then reach in the bag again and count it, then add that.
That's a lot of work.
That is a lot of work. I think the easiest way is to organize it in piles, right? Let's say you did reach in every time. You're like, okay, let's just put all the hundreds in a stack, well, 50s, 20s, 10s, and 5s, and 1s, and then the $1 coins, 50-cent coins, quarters, dimes, nickels, and pennies. You put them all together, and then you count each one up, right? And then you add those all together. Does that make sense? Well, that's actually what you would have to do if you worked at a bank. So I know that because I worked at a bank. So, anyways, people would come in with all sorts of money. So, what's that? Oh, I worked at a bank after In-N-Out. So now I'm talking about another job.
Did you ever get robbed?
Yes. Okay.
Really?
Anyways, so the objective of this lesson is how do we organize things and combine them into like terms, right? We're not going to combine all the hundreds with the $1 bills because then we get confused. You want to count things quickly, so you put them into organized piles, okay? Right? Does that make sense, everyone? So here are the steps for today. Ooh, excuse me. Here are the steps for today. Identify the different types of terms by any variables and their exponents. Then you identify the coefficients of each term, identify the operation, and combine like terms, and then write your final answer in descending order, okay? So just like you would have a big sack of money, you want to organize it, okay, so you know how much is there. If you don't organize your money, then you really don't know how much money you have. So it'll take longer to count it. Okay, so here you go. I'm going to do a couple examples. These are polynomials, okay? And you might think, oh, are they difficult? No, they're not. What we're doing is combining like terms. So we have a constant here of 8. We have r squareds, okay? This could be represent like, I don't know, $5 bills. R to the 4th could represent $100 bills. R to the 1st could represent $1 bills, right? So you're just combining like terms. So the first thing I want to do is look at the first term here, and we're going to start with the 8, okay? Or we could look at the whole thing, and we're asking ourselves, what's the largest exponent here? Well, it's r to the 4th, right? So we have positive 7r to the 4th, and we have a plus sign in the middle. We're asking ourselves, are there any r to the 4th on this whole side? Yeah, there's an r to the 4th here. So we're asking ourselves, what's 7r to the 4th plus 3r to the 4th, okay? When I do that, I get 10r to the 4th, right? Then I want to cross these out because I don't want to count them again. I know that I already added those two together. Then I ask myself, what's the next smallest exponent? R to the 3rd. Are there any r to the 3rds on the left side here? Nope. Are there any r to the 3rds on the right side? Yeah, there's one right here. So we're going to add a positive r to the 3rd. So when we do that, we get positive r to the 3rd. Cross this out. Now we're looking at r squareds. There's negative 4r squareds plus positive 7r squared. So negative 4 plus 7 is positive 3r squared. Cross these out. Lastly, r to the 1st, we have negative 3r to the 1st plus 3r to the first. Negative 3 plus 3 is 0r to the first. So we're not even going to use those. It's 0r to the first. So we're not even going to include those. And then we have constants, which is just 8 plus. Are there any other constants? No, so we just bring positive 8 down. And we're all done. We wrote it in descending order because I added it in descending order. We have 10r to the fourth plus r to the third plus 3r squared plus 8. And that's it. You box your answer. Right? Was that too hard? No. It just looks a little overwhelming because it looks like a big problem. Yes, sir?
What's the variable?
The variable could represent anything. It's just r.
Well, because like for the example, you said it was like money.
Right, you could say that these are like pennies. R's to the first are like dollar bills, $5 bills, $10 bills, $20 bills.
But what is R when you're talking about like it being money, like counting up all the money?
I used money as a metaphor too. R could represent anything. I just use it as a metaphor to organize you want to organize things. Okay. This isn't explicitly about money. This is just the polynomial. So, does that make sense, everyone? You're organizing things. Watch me do number 2 one more time. Here. Number 2. Okay, now we have our variables A. It doesn't matter what they represent. You could identify it as what you want, but mathematically we're trying to organize like terms together, so we're asking ourselves, what's the largest exponent? On number 2, the largest exponent is a to the 4th power. So starting here, we're identifying any a to the 4th powers on the left side. There's a to the 4th right here. We got negative 8a to the 4th. And then look at the difference here. There's a minus sign. We have to ask ourselves, negative 8 minus negative 3. How do you subtract a negative again? How do we subtract negatives in math? We're really adding, right? Same sides we're adding. So we have negative 8 minus negative 3 is going to be negative 5a to the 4th. Okay? And since we counted these, we crossed these out. Then we think, what's the next smallest exponent? A to the 3rd. Identifying any a to the 3rd. So we have 2a to the 3rd minus 2a to the 3rd. What's 2 minus 2? 0a to the 3rd. Now, since it's 0, we don't really have to count it. We could just leave it blank, okay? So, we're going to cross these out because we already counted the a to the 3rds. Next one is a squareds. We have negative 3a squared minus positive 2a squared. Negative 3 minus a positive 2 is negative 5a squared. Okay, cross these out. Then we have a to the 1st. Are there any a to the 1st on this side? No. Any a to the 1st on this side? Nope. Then we have constants. We have a 3 here. 3 minus a negative 1 is going to be, we're adding a 1, it's going to be 4. Positive 4. Therefore, your answer is going to be negative 5a to the 4th minus 5a squared plus 4. That's it. It's already in descending terms. Descending order. A to the 4th is largest, then it's a squared. Does that make sense, everyone?
Yeah.
Super easy. I think as long as you stay organized, you'll be fine, okay? You have to be organized when you do this. Otherwise, you'll have trouble. All right, so what I'd like you to do before you start writing is turn to your neighbor. 1 still at 2 is about number 1. 2 still at 1 is about number 2. Ready, set, go. All right, continuing on here, number 3, okay, number 3. So write this down in your notes, the whole problem, please. Don't finish it, just write down the problem, original problem in your notes. So you got 3n cubed plus 4n squared plus 6 plus 7n, all plus n plus 2n cubed plus n to the 4th plus 3n squared. So looking at this example, we have n is our variable. What's the largest exponent you see in the whole problem? N to what? N to the what? N to the 4th power. Good. So looking on the left side here, do we have any n to the 4th powers on the left side here? No. Okay. How about on the right side? Are there any n to the 4th? Yeah. So we're going to be adding a positive n to the 4th, right? So when we add a positive n to the 4th, it's just itself, right? We have n to the 4th. Okay. And we're going to cross that n to the 4th out because we don't want to count it again. All right. What's the next smallest exponent? Turn your neighbor, tell them what the next smallest exponent is. Okay, good. So we have 3n to the third here. We have 3n to the third plus 2n to the third. What's 3n to the third plus 2n to the third, everyone? What's 3 plus 2? 5n to the third, right? And it's positive 5n to the third, so we can put positive 5n to the third power. Okay, next smallest exponent, n to the...
Second.
Okay, we have n to the second, right? 4n to the second plus
3n.
3n. What's 4 plus 3? 7. Good. So it's going to be positive 7n squared. Okay, cross those out. What's the next smallest exponent? N, right? So we have positive 7n plus n is equal to positive 8n, right? Okay, I'm going to have you finish the problem off. There's just a little bit more. I'm going to walk around and check your work. Give you about 30 seconds. So last number is positive 6. We have positive 6 here, plus there isn't anything else, so that's it. Okay, this is your answer. Super easy, right? Let's do number 4 now. Number 4. What do you notice about number 4 already? You have to be careful with. Subtraction, good, okay. What's the letter? What's the variable? A to what power? A to the 4th, okay, good. So we have negative 5a to the 4th. Now watch carefully. Negative 5a minus negative 3a to the 4th is, what's negative 5 minus negative 3?
Negative.
Nope. Negative 5 minus negative 3. What was that? Good. Negative 2a to the 4th, right? Because negative 5 minus and negative 3, it's like we're adding 3. Good. Cross these out. Erase this a little bit so we have looks neater here. Okay. Next is a to the 3rd. We got negative 7a to the 3rd minus 7a to the 3rd. What's negative 7 minus 7? No. Negative 14a to the 3rd. Right? What's the imaginary sign? This is a positive sign, right?
Yeah.
Okay. So again, I'm going to erase it here so you can see it. Cross these out. Okay. Next one, a squareds. Are there any a squareds up here? Yeah, there are. There? Oh, I don't see any a squareds. So do we have to deal with them at all? No. Now a to the 1st. We have 3a minus negative 7a. What's negative 3 minus negative 7? I'm sorry, 3. This is positive 3. 3a minus negative 7a. What is it? Good. Positive or negative 10a? Positive 10a. Because you're subtracting a negative. Okay? Okay, finish up the problem. Okay, I'm going to come around and check your work in 30 seconds again. Ready? Go. Okay, so we just said 3a minus negative 7a was positive 10a, right? And then we have, let me cross these. Oh, excuse me. Lastly, we have negative 5 minus a negative 5. When I'm negative 5 minus a negative 5 is just 0, right? Plus 0, which is just, we leave it alone. So this is really your answer right here. Okay? So if you got that correct, good job. If you didn't, please fix your answers in your notebook. Did you get it correct? 10, 8, yes. Thank you. Okay, you guys got it? Let's keep going. Let's do a couple more. Excuse me, let me go back. Okay, number 5, all the way through. Go. This is what you should have had, okay? So largest exponent is x to the 4th, so we have 6x to the 4th plus negative 8x to the 4th is negative 2x to the 4th. Then x cubed, you have negative 7x cubed. Plus 6x cubed is negative 1x cubed, or just x cubed, right? Yep. Then we have x squared, 7x squared plus negative 7x squared is no x squared, 0x squared, so those cancel out. And then we have x to the first, negative 7x plus 2x is negative 5x. That's it. There aren't any constants, so that's your answer. Questions on this one? Raise your hand if you got it correct. Okay, a lot of you did, yep. Good. Last one. Okay, what do you notice about this one? What? Not shorter. What's the operation in the middle of both of them? Subtraction, okay. This one's by yourself. I'll give you about a couple minutes to do it. Alright, so look in here. The largest exponent is a to the fourth, so we have 5a to the fourth minus positive 4a to the fourth, which is just going to be a to the fourth, so cross those out. Then we have a to the thirds, we got 8a to the third minus 2a to the third, which is going to be positive 6a to the third. Cross the a to the thirds out, we're done working with those. Then we have a squared, negative 7a squared minus negative 2a squared, which is we're going to add 2a squared, which is going to be negative 5a squared. Cross those out. And lastly, we have 2a minus a is just a. There aren't any constants, so this is your final answer. Okay? That's it. All right? Happy face. Or is it really a happy face? Now it's like Batman face. Batman.
He looks scared.
I don't know. Didn't work. I'm not an artist. Okay, anyways. This concludes our lesson.